Bonsoir. Can you hear me? Sorry I'm a bit late. I want to send you this document that I'm demonstrating right now. I'm going to email that one to you too. How is everybody today? I hope you're well. Okay, I'm just sending you that document that is on display. And I called it 00 because it doesn't fall. I'd have to renumber all of the documents. Okay, let's just wait a minute for some people. Let's wait for 15 students. So I was pleased to see your work, students that sent me their homework. I was very happy with what I saw. Taylor's doing a great job, or you're doing a great job together, and that's a relief. So at the end of this weekend, on Sunday or Monday, I will send you the next assignment, all right? Now these are going to take me time to grade because I thought I had a greater research assistant, but I'm going to be grading, so it's going to take me more time. So what I wanted to do today was review and solve some of the problems you don't have answers for. That is the problems in document 10, number 10. So first of all, I just want to review what we've done so far. Actually, I'd like to look at this for a moment because I did see some of you using these formulas. Why is it blurry? Sometimes it's blurry. For interest rate conversions, I explained there are two relationships you need to know. How to convert between effective rates and nominal or stated rates. I also refer to them, call them stated rates. Quoted rates, that's the other word. They could be quoted rates. Okay, so stated rates are the same as quoted rates. Okay, that terminology is interchangeable. So this would be the relationship to convert between them. And then this is the relationship to convert between effective rates, from effective to effective, but you want a different time interval. And this is useful when well, you have many examples, you've seen many examples, but it's giving you the appropriate and equivalent rate over a different time period. And I just wanted to say that you can combine both of these, and I did see some of you were doing that. You can combine both of these where, for instance, let's say you were given for the mortgage, you were given information on the quoted mortgage rate, and you know you have to divide by 12 first. So you know you want to divide by 12 first. sorry, I did that wrong. So you get the stated rate as a monthly stated rate, and then you have to divide by 12 to get the effective rate. And then 12 of those becomes an effective annual rate. So I also saw you do things like this to make conversions. Okay, so that's combining this formula up here, relationship, and this formula down here. So I was happy to see that. And in general, oh dear, in general, the approach, so just to review the approach to evaluation, problems of evaluation can be solved systematically by using the following steps. I just sent you this document. First, you read a problem and you identify the timing of payments, if there are payments, and convert all rates, interest rates, growth rates, discount rates, to an effective rate that compounds with the same frequency as the payment frequency. You should also convert all other variables to the same intervals. So okay, so convert any other variables as well. Draw a timeline. So the second step. So once you have that, just to say, like if you're going to go for 25-year mortgage, would be, because payments are monthly, you would have to summarize or use 25 times 12. Right, 25 times 12 is 300 months. So you got to convert things to monthly periods. So that's the first step. Identify timing of payments and convert all variables to the same frequency. Second, draw a timeline and determine whether the problem involves a simple time value of money, an annuity with or without growth, or perpetuity with or without growth, or some combination of them. And then apply the formulas on the timeline where those patterns emerge. So if you see a pattern, like in the case of a bond, you see an annuity and a basic time value of money, face value of the bond. Those are two formulas, and you apply them where they are, and then in the last step, you modify the formulas to move lump sums to desired positions on the timeline. And then you add them together. So those are the steps, and then here's just a summary of the two relationships. Oh, this document got affected. Let me get the other one, the PDF, so you can see it properly. That's the one I gave you. And I just showed you how to address conversions if you want the monthly rate, but you're given a quarterly rate. Then you create the equivalency and you solve for the one you want. It's 4 quarters in a year and 12 months in a year, but it's also three months in a quarter. So algebraically, this reduces here and here, and it leaves you with that relationship. So you can go between any interval that we've discussed. And that's pretty much it. So you just have to practice, and I know I gave you a lot for a month, but you guys achieved. You did well. I wanted to spend some time on two things. One is the document called Discounting and Inflation, and the other one is this 10.5. So let's spend some time on 10.5 and, 10. Let's do this. Let me go back. I want to get 10. Good afternoon, everyone. So this is document 10. So all I've done, if you're coming late, is just reviewed some of the summary documents I gave. So this is document 10. Did you have a chance to attempt these problems, and are there any problems you would like me to solve on this document? I just sent you the solution set for it, so you could look at that if you like. So any problems on document 10 that you'd like me to solve? Noisy chair. I'm looking at getting a new chair. So the question is, are there any problems that you would like me to solve? Do you want me to pick one? I saw many of you chose to answer the bond questions, which was smart because they were straightforward. The other ones on the test had some twists. So does anybody want me to solve question number 1? Number 1 can hold. Okay, let's look at this one together. This is document number 10. Okay, so what we're going to do, our approach is going to be to use the information given, not look at the options yet. Don't look at those yet. Let's look at the information given and see what's asked about it. Okay, so in the first one, you have the face value, you know it's a 0 coupon bond, and you know its price. So what you can find here, you need the year, right? So this is missing year. Right? And B has 1,000, wait, and the, you're also missing, okay, you're told here about the yield to maturity, right? So you're missing here and the yield to maturity. So missing here. So you're missing T and you're missing I for our formula. But you're told here that all the bonds have the same yield. So let's see here in number 2, face value, it's a coupon bond, 25 years, and you're told that they're paid semi-annually. You should assume that bonds pay semi-annually unless otherwise told. So you have the coupon rate, which you need to adjust because this is a stated rate. And you'll need to adjust this, right? Because these are stated rates, and this is 25 years, so you have the time. So all you're missing here is the I. And then for C, you have the coupon rate, you have the same information, you're just missing I. So you can use oh, okay, no, number 3 also is missing the years. All right, so the first bond, you're missing years and the interest rate or yield to maturity. In number 2, you're just missing yield to maturity. And number 3, you're missing both. So why don't we use number 2, start with number 2, and solve for the yield to maturity. Once you solve it here, they should all be the same because that's what you were told, that they would be the same. So do that. Shall I leave you to try that? Give you a couple minutes. and then I'll write the answer. Okay, I'm gonna give you 5 minutes, all right? 5 minutes. Kinold, what are you asking about? Are you asking about document 10 or about the test? The test answers? Ah, the test. You want the answer or you want the solution? You want me to solve it? On the test, number one, on the test, $56,858.26. Are you happy about that? Is that the right answer? Okay, so let's continue with this question. Okay, so for this problem, you have to solve for the semi-annual rate Good afternoon, Natalie. So with the information given, I always start this thing by accident, and I don't know how to stop it. All right, so you're given information that the coupon rate is, well, you're told the coupon rate is 6%, but that's 6% divided by 2, right? Because it's seen as a quoted rate. So what you're supposed to do to get the payment, it's equal to C times face value. 0.03 times 1,000, or $30. So that's going to be your semi-annual payment. And then you need you want to find, given the information, the price is $1,170, and this is equal to the annuity of $30 over the effective half-year rate, which we want to find, and then we put it in the formula. We have to present the whole formula, and you're told the years are 25. 25 years is equal to 50 semi-annual periods. So that's 50 there. And then don't forget to add the face value of the bond, and that's going to also be for 50 years. 50 periods, sorry, 25 years. So this is the formula that you need to solve, and you cannot solve this directly because it's impossible to isolate the interest rate. So you use your finance calculator to do it, entering into your calculator from left to right 50 into N, and I is what you want, so don't put anything there. PV is the amount, and you can make it a negative with the idea that you have to purchase this bond to get the return. So you have to keep that in mind. So that goes into PV. And then payment we said was $30, which you will receive, so you make it a positive. And then the 1,000 is for face value. And remember, for the coupon bond, you fill all the keys, you enter something into all the keys of your calculator in the time value of money row. So then you can compute I, and this will give you the effective semi-annual rate. Good afternoon, Jonathan. Oops. I want to see. Okay. I have to see what you did on the test to get it, wrong or right. Okay, so here, entering 50, 1170, 30, and 1,000. So 50 into N, 1170 in negative into PV, 30 into payment, and 1,000 into FV, compute I. So that is the interest rate, 2.41120. And that is going to be the effective semi-annual rate. But it's not the stated rate. So depending on how the question is phrased, you have to see. So what do they say? Oh, I keep on jumping out. Okay, so it says here that the yield to maturity on all the bonds is 2.4 per year compounded semi-annually. So that per year semi-annual, that's a stated rate. Our answer is that 2.4 is the effective rate. So that's not correct. So A is out. But now we have the effective semi-annual rate, so we can solve for B and C. So now you're going to solve, so this would be like step 1. Step 2 is to check with that rate, check if 16 years are the years to maturity for bond A. So for bond A, here's the information. It's a discount bond, pure discount, and you just got the, okay, so what you got is the effective rate semi-annual. You need to convert that into a effective annual because there are no coupons here. There's 0 coupons. It's just this is the price and this is the value in T years. That's it. There are no payments. So we need to do this, get EAR first. So from here, you take this amount So that's the rate. I'm going to move this all over. So this is the effective annual rate that we computed, and we should store this in our calculator because we're going to need it. So this should be stored. And what you want to do with it is you want to convert it to an effective annual rate. And you guys know by now that given this, but you need this one, the relationship between them 1 plus EAR is equal to 2 semi-annual periods compounded. So what I have to do, all I have to do to get EAR is compound this twice and take off the principal. So I'm going to recall that amount in my calculator and figure this out. So let's see, back to the calculator. We're going to store this value there it is, but it's added as a percentage. So what you have to do is divide it by 100 and put it back. And what you want to do is you want to add 1 what just happened. Let's do compute I again. And then we're going to store it in 1 and divide by 100, sorry. Store it in 1 and then add 1, square it, and minus 1. And this is the effective annual rate, 0.0488. So practice doing that. Now once you have that, you can figure out the years at that rate. It's about 5%. How many years with with this rate per year does it take 685 to become 1,000? That's basically what we have to sort out. So now what you're going to do is you're going to write up the formula for 1,000 is equal, no, that's not right. We're going to write the formula for the discount bond. So $685 is equal to pure discount 1,000 discounted by 1 plus effective annual rate. And we want to find T, how many years? So what I'm going to do is take this amount, put it in my calculator. I have to multiply it by 100. So what I'm going to do is put that in store 2. You could have done this with a semi-annual rate too, but it's okay. Either way is fine. So you put this in store 2. So what you have to do is enter, N is what we want, I is recall 2 times 100, and you put that into I, and then PV is the price, which is 685 negative. And then the face value, well, PMT is going to be 0 because there are no payments. It's just one amount, one lump sum. And then the face value will be the 1,000 that you get. Then you ask the calculator to compute. You want to compute n. So let's do that together. Gonna go back and take this value and store it in 2, and then I want to find n. I'm going to recall this and multiply it by 100 to put it in the interest. I'm going to put 685 negative into PV. There are no payments, and then I will earn $1,000. So I ask to compute n, and I get this number. And so that's just about 8 years, right? Now I go back to years because it doesn't matter. There are no payments. When there's no payments, and I'm just looking to see how many years something, an investment takes to mature, or this bond here takes to mature, then I can use years. Are there any questions about what I'm doing? So when you compute, you get 7 point, what was it again? 7.93959. 7.93959. I gotta go back. 7.939. 7.93959. And this is in years. I'm gonna see if I did that right. Looks like I did something wrong. No, that's fine. All right, so you're gonna do it again. You guys are very quiet. Hello, everyone. All right, let's do this again because just to do this again. So I'm going to, I have in store one this amount. And I convert it to an effective annual rate like that. So I add 1 and I compound 2 factors of the half-year rate. So now I have the annual rate, and then I multiply by 100 to use it. But for now, I've put it in here, and now I want to know for this rate and bond of $685. Is that how much it is? $685. Yep. $685. With no payments and $1,000 face value. I'm going to do the 685 again. 685 with a negative. And now I'm going to ask to compute N, and that's the answer. So it's almost 8 years. So it's almost 8 years is the answer. And what was the statement that we are assessing? We're assessing the statement here. The bond A has terms of 16 years, so that's not right. It's 8 years, so that's wrong. Bond C has a term, so if A and B are wrong, then E cannot be right, because that includes A. And we're down to checking C. Bond C has term to maturity 4 years. So you have to check this to see if it's 4 years. Can you guys check that for me? So we've done step 1, step 2, step 3 now is check this bond for how many years? Okay, so try this. So you're going to verify if it's 4 years or 8 semi-annual periods. So I'm just going to make this big and do it right here. So here you have a formula. So I always have to write the formula, right? You have to always write the formulas out for the test, so I'm always going to write them out. So the price here is $860, and it does have coupons. 8% coupons are really $40 payments every semi-annual period. And we know the effective semi-annual rate that we already calculated. And that's for what we want to know is how many periods, and then we have the face value of the bond. For also the same amount of periods. So this is the formula. Now we put everything into the calculator. and we hope it's going to be 4 years. So $860, $40, and we already have the stored. This is the rate, so I'm going to multiply that by 100. And what I'm going to do now, what did I just do? Sorry, recall one. I'm going to multiply that by 100 and put it as the interest rate with $860 spent for the bond, and the payments are $40 that are received plus the $1,000 face value that is received. And now we get to compute N, and it's 8 semi-annual periods, and if you divide that by 2, that will be 4 years. So 8 is answer. Well, why is it negative? Let me do this again. Why did I get a negative? Recall 1 times 1,000, 100. Put it into the interest rate. PV is 860 negative. Payment is 40, and the face value is 1,000. And now I compute. So that doesn't make sense. It's a negative. So that's a tricky one. So the answer is, since this doesn't work, that means it's like undefined. That doesn't work. Basically, it's not possible. So the answer is none of the above. So I know I give you a lot of problems, and do your best to prepare them, and then we'll do some together so that you have a nice set of problems, and you keep working on the problems we covered in the previous weeks, even though we're on to new material, right? You want to make sure you have competency in all the areas. Okay. Any questions? Was that confusing? So basically the answer here is undefined. Or indeterminate. You can't have a negative set of years. Comments? So you can play with those. You have the solutions to this whole data set now, question paper. Now, what I wanted to do together was solve some questions with stock that have let me see which one I want. Let's do number let's do number 2 together, and then we'll do the other one. So let's try number 2. So why don't you try that? Let me know where you get stuck. If you have difficulty. So for people who just got here, this is document number 10. The one I did not give you solutions for. I've given you them now, though. I just sent them to you. Okay, how's it going? So let's use the information to present the perpetuity. You're told that annual payments on a growing perpetuity will start 4 years from today, and it has been determined that this first payment will be $6,000. So if I was to draw the timeline, so it starts 4 years from today. 0, 1, 2, 3, 4. So this is 4 years. I always note what is the interval of time. And it's going to be $6,000. It is known that the investment that needs to be made today to fund the perpetuity is $48,000. $921.19. Assume the effective annual discount rate applicable to the perpetuity is 13%. So this is the rate you're going to use, 13% a year. And we assume that's effective. That's really important. So that's the effective rate. That's what we use. Only effective rates go into our formula. The effective annual growth rate, that's good. That's also effective. It reflects exactly what you really are going to be paying. Sorry, in interest or earning in growth. What just happened? So you want to find the growth rate. So this is a growing perpetuity, you're told. So you want to find the growth rate. So what we know so far is the first one will be here. And then because it's a perpetuity and it's growing, we know this one will be 6%. Sorry, not 6%, but 13% will be the growth rate. And then it goes on and on forever. Year 5, year 6, year 7. All I needed to know though was the timing of the first one, because the formula tells me that, remember, the formula would apply one period before the first payment. So C3, sorry, the PV3 would be the present value of growing cash flows, with the first one as 6,000 and then the next one as I minus G. That's the perpetuity formula. It goes like this. You just need the first one divided by I minus G. So all I found out is the price here, but I'm given the price here, so I have some options. I can either adjust this price to time 3 or discount this 3 periods back. Either way, it's the same relationship. The relationship is going to be or let me move that over. I'll move it over here and I'll write it as 6,000 I minus G, but then discounted for 3 periods. Any questions? Everybody follows? Since the first one is here and the formulas always start one period before, this formula would give me the indefinite cash flows starting at 4. So that will convert it into a value. I don't know G though, I need to find it. So this would be the price, and then I need it in terms of times $0 to match with this. So that's why I use 3 periods of discounting. So then I have to use algebra to solve for G. Okay, so this is just mathematics at this point. The finance part is knowing which formulas to apply, how to use your calculator, and how to interpret questions and findings. So when you solve this for G, you get 4.5%. I'll just give it an asterisk. That's what I want to solve for. Okay? Any questions? Now the test questions, most of them you have some variation of them in your notes. So if you want me to answer any test questions, I can do it tomorrow. But right now, I just wanted to do one more problem and then go into the new material. Someone just wrote me, Samuel wrote, "Teacher, I thought you would use the formula having I, G, and T." This is a perpetuity, so there's no T. So it goes forever. You don't need it for that one. Okay? More questions? Let's see. Okay, let's look at number 8 from the test. Did anybody do number 8 from the test? Okay, these are the answers. Well, 7 and 8. I'm just going to take the question and I want to take 8. Oops. Actually, okay, I'm going to take 8. All right, how many of you actually did number 8? We're going to solve 8 right now. On assignment or test, however you want to refer to it. No one did 8. You did? Okay, let's do this one. What did you get, Kendall? What was your final answer? You didn't do 8. You did 9. Oh, you did 8. Sorry, my eyes. I have to put my glasses. You did 8. Okay, so what did you get? What was your answer? That's not the answer, but let's look at it together. Okay, I think it's worthwhile because I didn't do anything like this. It has components of things that you know, but Kenold, you got part of the answer. You're missing some part of the answer, but you got part of it. So you'll score all right. Okay, you didn't get the whole answer though. You missed some of it. All right, so let's see. Jovan Novelty Products has decided, yes, Natalie, you missed some of the answer, has decided that its dividend policy should reflect company growth. They indicate that the first annual dividend they intend to pay will be $2.50 per share 3 years from today. Yearly dividends, it should say, will then increase at a rate of 6% per year until the end of the 8th year from now, and then grow at 3.5% per year thereafter. What share price should you pay for such a stock if you expect an effective annual rate of return of 15%? So what you have, well, let's see, only a few of you tried it. Let me give you, maybe at least draw the timeline, okay? So draw the timeline. I'll give you 5 minutes to think through this. And some people, if they feel they need a break, can take a break. Okay, so draw the timeline. Okay, how did your drawings go? Did you draw the timeline? So the timeline so I'm gonna make this bigger. Decided that its dividend policy should reflect the company growth. They indicate the first annual dividend they pay will be 3 years from today. Okay. So today is 0, 1, 2. So 3 years from today, 250. What am I doing? I don't know what I'm doing. This is 3. This is 250. I think I'm just tired today. Yearly dividends will then, this is will then, will then increase at a rate of 6% per year. Okay, so then growth kicks in at 6% per year. Until the 8th year from now. So this will be the first dividend. This is the next dividend in year 4. End of year 4. Then year 5 it grows and it grows and it grows, and I could write them all in, and this goes on to the end of the 8th. So how many periods of growth would that be? It's 1, 2, 3, 4, 5. So it should be, this should be 250, 1.06 to the 5. Do you agree? 1, 2, 3, 4, 5. I'm going to move it over just a little bit because I need room for the next one. And then I really need this one because the next one changes. So in here, it's 3.5, sorry, 6%. But then after that, it'll grow indefinitely at a different rate. All right, let's see if you follow my logic. So I've just put in the key amounts that I need. I need to know the first payment and when the growth kicks in. And again here, and I always take it back. Actually, I should put this all the way back to 2, right? Because my formulas tell me the value one period before the first amount. That's just the limitation of the formula. You can think of it as a limitation. Or just the way it is. So this is differential growth. The dividends grow at a different rate, and now you have to consider present value of the future cash flows with all the assumptions included. So here's the thing. The only thing that's really a perpetuity is this part. From here onward would be the perpetuity. Remember, I'm starting here because it has to be one period before the first one. Now this would be the first cash flow, and the next one would be the growth. So I have to write that one in too, don't I? Let me get rid of this green for a minute. So that's 9. Let me rewrite that. I'm going to make this big again. So I need to write 9 and 10. So 9 would be, it would be the amount of the dividend last period times 1 factor of the new growth rate. And then 10 would be the same one that I had before in 9, but 2 factors of the new growth rate, and then this goes forever. So why did I do that? To show you that we need C1, right? The formulas require C1. C1 is the first one. So the first one for us at the beginning, I'll use black. So this would be like our C1, first cash flow. And it would be the C1 for a growing annuity that ends here. So between 2 and 8 is an annuity. So that's a shocker, right? This is the annuity piece. And we're going to add the present value of this annuity to the present value of this perpetuity that starts at 8. This would be like the C1, the first cash flow. And then this is C2, and this is 1 period of growth. So how do I put this together? And I sent you the answer so you can look at it there as well. We will have a PV2 2 for this portion, which is a growing annuity with the first cash flow of $2.50. The rate throughout is, 15%. Okay, so throughout it's 15%, so I put 1.5 as I, but I have to use minus G, right? That's going to be I minus G here. So 0.15 minus G, which is 0.06. And then I multiply it with, remember the formula for growth where I have G on the top and the discount rate on the bottom, and it's all to the power of how many periods. So how many periods are there in this annuity? 1, 2, 3, 4, 5, 6 payments. So that is what the T is. So that's that part. The next part, which I will add, but they all have to be converted to time 0 in order to sum them. The next one would be valued at PV8, and it is a perpetuity, with the first cash flow being this, and it's growing at a rate of 3.5. So the first cash flow for the perpetuity is $2.50, 1.065, and then 1.035, and it's growing, so it's 0.15 minus 0.035. All right, questions? Questions? So you could call this first part A if you want, and the next part B. So then what I want to do is discount this 2 periods to get it back to time 0, and I want to discount this one 8 periods to get it back to time 0, and then add the 2 parts. It is very complicated, Justin. There's not many problems like this, but you should understand this. That's the most important thing. Maybe you won't get it completely right, but yes, it's complicated. But you guys are good at math. So if anything, the main things you should know, and I have no mercy for, is that this one starts 1 period before, and this one starts 1 period before, and I discount and sum. So the students that got $9.84 only focused on this portion. They neglected this portion. Okay? And it's understandable, but you get half the points, at least half the points for that effort. So what has to happen now to put this back here, I need to do $2.50. I'm just copying. So that would give me PV part A, discounting 2 periods back. And then this portion here, oops, would be the PV0B, which would be discounting it 8 periods back. And again, I'm just copying what I had, $2.50, the 6 periods of growth to bring it, 5 periods of growth to bring it to year 8, and then 1 period of the new growth rate, and it's a growing perpetuity, so that's that. So when you put these two numbers together, let me write it again, it's a little bit messy. I'm going to write it down a little lower. So it's here, 250, 1.065, 1.035, and then the bottom. And this part gives you $9.84, and the other part gives you $8.12. So what I'm going to do then is sum them. So your final answer is $17.96. So the students that attempted this, you just forgot this part. So what I'm going to do for the remainder of the course on the test is I will have a portion of the test you have to answer, and then I'll have a portion of the test you can choose from. The portion where you must answer will be questions from the previous material. All right? So for the next test, for instance, I'm not going to, I guess I shouldn't say any numbers, but something like you just had. 4 questions is all you have to answer. So you get to choose from a set of problems for one part of the test, and for the other part of the test, you have to answer the one I give you, okay? So, any questions? This is the final answer here. It is complicated, but it is tough for our brains when we're learning, but then once you see through, it's very clear and you see the pattern that repeats. So I already gave you that solution, so you have that. No, this is from the test, right? This one you don't have. I guess I can send it to you. I can send you the test solutions. I don't like to because then I have to make up more questions, but let's see. Send you test solutions. All right, it is 6:45. We have about an hour to start the new material, unless you have a question for me. Do you know how to enter all of this into your calculator? No questions, okay. So I looked at the review problems 10.5. There's also this document 11 that's important. So I'll look at this tomorrow, but you can review. I don't know if you're going to have time tonight, but we're going to look at this tomorrow, okay? So review for tomorrow. You have the solutions as well. This is document 11. Okay, so now what I want to do is start the new material. Document 12. So we've spent last week and a little part of this week learning about valuation, and I taught you how to value assets like stocks and bonds, and I taught you about mortgages, and we learned about valuation, but we also learned, given a valuation, can you find other variables? So we learned quite a bit, and what we want to do next is value projects. We want to use our valuation techniques to value alternative projects for investment and determine which one or which projects we should invest in. So something like the hotel discussion, where we use the net present value to evaluate whether we should invest in a hotel or not. Okay, so that's what we're going to spend some time on. For the answer for that one was 17.96. This set. It was 17.96. Yes, Samuel. So what we're going to do, I'm going to start on, this is document, this is document 12. Let me see. It was 812 and 984, 17.96. Okay. Ready? So there's different kinds of decisions we can make. We could evaluate a project to determine if it has merit and then pursue the project on its own merit. Or we could have a situation where we have several projects to choose between, and in that case we have to pick only one. So if it's a case where you're just evaluating the project on its own merit, it's called independent project analysis. If you have to choose between projects, this is a mutually exclusive project analysis. Okay, so you only get to pick one of several potential projects. You will rank the alternatives and pick the one that's best. And third, you could have enough capital, enough financing to back several projects. So that's known, maybe several, but not all of the alternatives. So how do you choose the best combination of projects with the available financing? That is known as capital rationing. So you have enough capital to invest in more than one, but not all the alternatives. Okay, so we are going to spend a lot of time on independent project analysis, and then at the end I will talk about choosing between projects and having to choose and to leave some behind. But you get to choose more than one project. Okay, so ready? So as I mentioned, we already done this before using NPV. I want to keep in mind there's an art. I want you to keep in mind there's an art to valuation, and it involves you anticipating through estimation, through past experience, through some connections in the industry or the sector, that you're able to gather information about what kind of cash flows can you expect in terms of revenues and expenses as a result of the project. You want to include those in your project analysis or valuation. So the amount of cash flows are important. The appropriate risk-adjusted rate of return is also important. You have to figure out what is the right one that I should use in my project analysis. And we'll talk some about that. And finally, the timing of each of these cash flows, determining when are they coming. And most of the time, I've already mentioned to you, we work with end of period cash flows as an assumption, but cash flows can accrue throughout a period, okay? But we're going to stick with end of period most of the time. All right, so with that information, you could use a net present value analysis. If you remember the rule, you need to know the initial investment, and you see if the present value, the total present value of future cash flows is enough to offset the initial investment. So again, in estimating NPV, you're going to need to know the estimated initial cost, the estimated future cash flows, how much and when, and of course, you need to have estimated a discount rate that you should use. So lots of estimates go into this. So you might want to do this several times with different estimates, right, to evaluate your project. Whether you're doing it for your own business or you're doing it on behalf of a company, you need to be able to communicate your results at the end. And NPV is easy to communicate. If the NPV is positive, we accept the project. It shows that it's a profitable project relative to the expected return in financial markets or any other projects you could be pursuing. And that's accomplished by using a discount rate, which is the required rate of return for this investment or any investment that you would pursue. In independent project analysis, you pick the projects that have positive NPV. If you only have the resources for one project and you have to choose between two, you're conducting a mutually exclusive project analysis. You would rank the NPVs, so you would put them in, you would calculate them and then say, we choose the one with the highest NPV, the most profitable project. So let's remember how to do this. Here's the first example. Assume you have the following information on project X. So for this material, this unit on different evaluation techniques, I'm going to give you the cash flows. In the next module, we're going to talk about how you actually create or estimate these cash flows themselves. Okay, but for now, I'm going to just give them to you. So here we have the estimates of revenues and expenses. So I can calculate net revenues here. This is the estimated initial outlay, $1,100, and this is the required rate of return. So this means that if we didn't pursue this project, we have an alternative project where we can get 10%, whether that's some other operations of our company, or let's say we have, we're aware of a company that is very prosperous, doing very well, and you can get 10% return, so you'd rather invest your capital over there than to put it into this project. So that's how we think about this required rate of return. It's our opportunity cost for investing and tying our money in this project. All right, so what we see are in the timeline we see the initial outlay, and then we calculate the cash flow from the first period. We would discount that one period. The cash flow from the second period would be the net revenue in the second period, and we would discount that. Okay, so don't forget what we've learned, that we discount each because of the time value of money effect. We need to discount them and sum them all at time zero. And this is accomplished very easily using the CF keys of the calculator. So let's practice doing that right now. So use the CF keys of the calculator to get the answer. So the amounts are 1,100, 500, 700, negative 500, and 1,200. So I'm going to go to my calculator now. Sorry, I'm having issues here. Give me a second. All right. So to put these into our CF keys, oh no. I have to reboot. You see that? Okay, so CF. And then we put in 1100 negative, enter, down. Oh, there was something in there already. Oh, we have to clear. Let's clear CF first. So CF, and then we say second clear work to clear the worksheet. Okay, so now we use 1100 negative, enter. That's the initial outlay. Then the net revenues are 500, enter down, frequency 1, so enter down, just arrow down, and then 700 is the next one, down, down, and then 500 negative is the next one, down, down. Remember frequency 1, so that's already set. And then 1200. Down, down. Are we finished? We are finished. So let's scroll through. make sure we have it. Negative 1100, 500, one of those, 700, one of those, negative 500, and 1200. Okay, so now let's ask the calculator for NPV. It needs the discount rate of 10%, which we determined we should use. I gave it to you. And then you arrow down and ask to compute. And that's the answer. Can you get that answer without me? Would you like me to do it again? So once you've calculated the net present value, it means that the benefits, which are the present value of the future cash flows, exceed the cost. So this project on its own merit is profitable. So you should pursue the project. I've left notes space in your notes so you can write, the steps in case you forget. You can also just watch the video again. So that was just a review of net present value. Does anybody have any questions about how to use it? Use the CF keys. You do not want to be handling that manually or by hand. It's not practical. No questions? Everything's good? Did you get the answer? Someone confirm they got the answer? Oops. No one got it? Did anybody get it? Okay, I'm going to have to assume somebody got it. So this is the net present value. We've already discussed it before, and so this was just to remind you how to use your calculator to solve. In addition to the net present value rule, which you understand in practical terms, why we use it, because there's a time value of money effect, and we will discount future cash flows because they're not as valuable as current or in the near future cash flows. So they're not all worth the same. $1 today, not worth the same as $1 in the future. it's worth more. Oh, to clear the CF, remember, it is to be in CF, so hit CF, and then second, clear worksheet. Second, clear work. I'm not hitting it. Second, clear work. There. Now it's gone. So you have to be in CF, second, clear work. If you're not in there, it's impossible to clear. Okay, other comments? Okay. So net present value uses all the cash flows, and it requires you have a discount rate in order to evaluate, right? In order to discount those cash flows. So you've had to make some decisions in order to do that. That can have limitations if you don't really know which discount rate you want to use. It's possible you could be, maybe you have you'd like a better idea of what discount rate you should be using to make it profitable. And we'll talk about a different kind of method that helps you do that. In the meantime, we're going to talk about a common method to evaluate projects at the outset. Business owners could say, well, I'm going to invest some money, but I need my money, I need to recover the costs, the initial costs of my investment within a 2-year period, or I'm not going to pursue the project. So that's a different approach. They want their cash back within 2 years, or they're not going to pursue the project. So future cash flows are irrelevant. The only ones that matter are the next 2 years. Now, this is sort of common. It's a common kind of thing that people look at. Right? It's a very practical question. So I'm going to teach you how to compute that the best, more as precise as we can get. Again, given assumptions inherent in estimating all the cash flows, we can do that. So this approach does ignore time value of money, however. If you don't discount the future cash flows and you just add future cash flows together, you've neglected to consider timing, the time value of money. So let's do two things. Here are the cash flows for this project. The initial outlay is given here, and the cost of capital is 10% once again. And the question is, what is the payback period, and then what is the discounted payback period? So let's find the payback period first. The payback period that would be the time it takes to recover your costs. The costs were $1,000. So looking at the cash flows over here, I'll move them over. So looking at the cash flows, when do you make your $1,000 back? Well, year 1 is not enough. Year 2 is not enough. So somewhere between the second and end of the 3rd year, you will have, so somewhere in the 3rd year, this is the end of the 1st, this is the end of the 2nd. Someone in your 3rd year, you will have your you will have recovered the costs. To be precise, we can make a calculation. To be more precise about that, we could say so I'm going to use payback period would be equal to 2 years plus what remains to be recovered. So it'll be 1,000 minus the 600 already obtained, right? So this is 600. And then I want to distribute that over the fraction of the next year. So that's $700. So this gives me the fraction of a year that it'll take to recover my costs. So when you calculate it, it's 2.57. So that's known as the payback period. So it'll take 2.5 years to recover costs in this project. Questions about what I did? So this amount is like what remains after the second year, and this is the cash flow in the third year. Completely ignoring the other cash flows because either the partners or the CFO or the CEO of a larger company or corporation wants to know from the finance office or finance department, when will we recover our costs? Everyone okay with my calculations? Now, what if we wanted to include time value of money? So to include time value of money, we first have to discount future cash flows. So discount one by one. This one, let me show you. Let me make this bigger. So let's discount each one in turn. So 200 divided by 1.1 gives 182. 400 divided by 1.1 squared gives 331. 700 divided by 1.1 cubed gives 526. Okay? And 300 divided by 1.14 gives 205. And so then we want to find the discounted payback period. To do that, we use the same approach as I did above, but now I'm going to refer to these amounts. And it would be helpful to make another column where I add together these amounts to see where I approach 1,000. So just these together would be 513, and then adding another 526 would give me 1,000. So look, closer to the end of the third year, we'll recover my $1,000 investment. So you do the same calculation. You get the closest year, which is 2 years, and then you add the fraction remaining. So by the end of the second year, you would have recovered 513, which is a cumulative amount of those two. So what remains is 47, and you spread it over the third year, 526. So it's the same formula that I just used, but for this different data set. So this would be that amount, and this one is that amount. And now you see it takes longer to recover your cost because of time value of money. Future dollars aren't worth as much. So it's about 3 years as opposed to 2.5. So the payback period would be 2.57. The discounted payback would be 2.93 years. And if you only are allowed to pursue projects, or if you have established you're only going to pursue projects that pay back in 2 years, then this project will not pass. It will not be accepted. We say it's not acceptable if 2 years is the cutoff or the threshold. Questions? Okay, so yes, Jean is asking, how do I include the other years? Well, see, this is something different. This doesn't care about the future years. It just cares about the short term. Okay, so if to include future years, you would use NPV. Now, it's not unlikely, it's not unheard of that someone will make a decision using both NPV and either one of these rules, payback period or discounted payback period. Okay, so NPV uses all the cash flows, and that's really important because what if in the fourth year, what if this was not 300, let's say it was 300,000. If that was 300,000 that's coming in the fourth years, do you really care to cut off projects if they take more than 2 years to pay back? Maybe not, but you would be completely ignoring that. So that's why it's important to use NPV alongside this kind of analysis. So you take account for future cash flows. That might be really good. What if it wasn't 300,000? What if it was negative 300? If it was negative 300, and let's say the threshold if the threshold was 3 years, you would accept the projects. But if something like this, there was a negative 300 out in year 4, you might not want to. So my conclusion is payback period is good, but you probably want to also include a net present value analysis. They're complementary analysis in that case. Okay, good questions. So these are just some disadvantages, like I mentioned, that another thing you have to determine is, management is going to say, well, we want the project to pay back in 2 or 3 years. It's still not, that's very subjective. Just looking at the cash flows, maybe you can change their mind if they could wait around for future cash flows. And that's a big point. If you don't consider all cash flows, you're missing important information about future, possibly detrimental or windfall, large cash flows. So the resolution is you don't use the payback period or the discount payback period alone. You want to use it with something like NPV or what we're going to talk about, the internal rate of return. To call it a technique. I'm going to call it metric. So that brings us to the internal rate of return. So far we've talked about NPV, which gives you a dollar amount, and we talked about payback period and the discounted payback period, which gives you like a time amount. And next we're going to talk about IRR, which gives you a percentage as a metric. And I'm going to skip this page. I will come back to it, but I'm going to go and demonstrate an example to make it meaningful, and then we'll go back to the intro page in a moment. So this is an example of the internal rate of return. With these cash flows and this initial outlay for a project, say we don't have the discount rate handy. We're not sure what the discount rate should be for this project. So you can find IRR without the discount rate. Or, what I call the required rate of return. But you're going to need one, like in the end, we want to compare what we get to something. And that would be the required rate of return. So what is the IRR? It is the discount rate that gives us a break-even project. So NPV of 0 would be break-even. No profits, but no losses. Okay, so that's 0 would equal this. So this is, you can interpret IRR as the return on investing in the project. It's a percentage return that reflects the return on investment for the project. So with these cash flows, you could see it like this, or I could write this in this way. So what I want to do is I want to find the rate that solves this amount equal to 2,200. Now, presumably, as the discount rate goes up, as this goes up, these denominators will go up, and the overall thing goes down. Now this side will stay the same. So as we increase, or in trying to find IRR, we are not going to solve this analytically. We're not going to try and isolate this term. What we're going to do is use our calculators, and the calculator will use an iterative procedure that's been programmed to try and identify this. And I'm going to demonstrate, and we're going to use a method similar to what the calculator would be doing to solve this. Okay, so you cannot isolate the internal rate of return to solve this problem. You need to use your calculator and the IRR function. So I want to show you how to do that, and then we'll talk about what it means. Okay, so let's see. Going to the calculator. Okay, we're going to clear work, and let's enter these values. So enter them as usual. 2200 negative, enter, and then scroll down and enter 800, and it's going to be down and down. Second term, 900, enter, down and down. And the third one is 500, enter, down and down. And 1600, 1600, enter, down and down. So we've entered everything. Let's check to make sure we did it correctly. 800, 9, oh, I missed that one. 900, enter, down, down, and the third one is 500, and the fourth one is 1600, and that's it. So everything is in there, and now what I'm going to do is hit IRR, but it says 0, so I have to ask it to compute, and there it is. So the calculator does it very quickly. So I'll give you a few minutes to try that. You got it? So CFO, oh, you don't have the notes in front of you? 2,200. 2,200. Oh, CFO, what means, oh, you asked what does it mean? It's the initial outlay, it's the initial investment. So you invest this amount, and these are your net revenues each year. Okay, so what does this number mean? 23.29. This is the return on investment, so it's 23%. Actually 24, because it's, if you rounded it, it would be 24. So, all right, so what's going on? I left this page blank that you could write notes in if you print your notes. So what we've done is computed that $23.3, sorry, yes, 23.3 is the answer. So we found the result is 23.3. And what does it mean? Here is a graph depicting net present value on this axis and different discount rates that go into the formula on this axis. And as I explained to you, this formula here, which I will copy and bring over, well, I'm gonna bring the whole thing. Oops. Okay, so this is the formula here. So as the calculator considers higher and higher values of IRR to put in there, it calculates this side and verifies how close it is to here, or it offsets it by the initial investment and says how close is that to zero. So as you're including higher values for the discount rate, this is going down. And same thing here, because this is a negative and this is going down, it's just going more negative, right? So it's the same thing here. This is just going down. So that's a down sloping monotonous function like this. So it plots picking different discount rates to calculate the NPV. It goes like it's tracing through like that. Okay? And it's going to the point where your discount rate gives an NPV of 0, and this is where you find the IRR. Why is this important? Well, the net present value is positive for all of these discount rates. You see, it's in the positive region. So as long as the discount rate that your company wants to use, the required rate of return, as long as it's less than the value you found for the internal rate of return, you should accept the project. You should always accept projects as long as the internal rate of return exceeds the required rate of return, because it's here that NPV is positive. Otherwise, this line is going to be negative down here. Okay, so you don't accept, you reject projects that are down here. All right, are you with me? So it's the return, the IRR is the internal rate of return, and it reflects the return on investment in percentage terms. So for instance, our IRR was 23.3. So the return on investment is 23.3. Is that good enough? Well, it needs to exceed, it needs to be better than the required rate of return. That's my notation for required rate of return. So if your required rate is 15%, yes, accept the project. However, if your required rate of return is higher, like 25% return on dollars invested, then you should reject the project. Just before we go, I want to talk about the NPV profile, and this is where we're going to start tomorrow in the afternoon. This is generating that line that I just demonstrated here, this NPV function. Okay, so this is the NPV function. This is actually this one here. I will erase this one because it is the NPV that we're calculating. So as IRR goes up, NPV goes down for this function. So if you were to pick and use different discount rates, you would get these different NPVs. So for instance, I have all these numbers in the calculator already. Let's see if I can generate these values. So if I go back to the calculator and I put 0 in the discount rate, the NPV should be 1600. So if I go back here to CF and I ask for NPV and I put 0 as the interest, then I can ask for NPV and you see 1600. So what we're going to do is we're going to put different values of the discount rate in the formula in the calculator and generate what's called the NPV profile. So I got 1600, so this is correct here. What if we set the discount rate to 5%? We should get this number here. So if I go back and I set the discount rate to 5%, so I'm going to hit NPV again, I'm going to use 5, enter down, and then ask to recompute NPV. And there it is, 1,126.47. So that's 1,126.47. 1,126.47, you see? So let's keep going. We're going to keep going until the NPV becomes negative. When it becomes negative is where we know it crossed the line, and NPV is 0 in here somewhere. So it tells me that there's an IRR between 20 and 25. Okay, between these two. So let's keep going. 10%. So again, we do this because we don't know what discount rate we want to use. We just want to see what would be the threshold to pursue this project. So let's put in, what did I say, 10 or 15? 15, enter down, and recompute NPV, 419.74. So that's for 15. 419, I think I had to do, there's 419.74 for 15. If I put 10, I would get this value. If I put 20, I would get this value. If I put 25, I would get this value. So the calculator, what it does then is it knows there's something in between here, so it just plugs values in, just like we are. And it iterates closer. So what it will do is expand. It'll expand this range, and it will use values like 21, 22, 23, 24. And it will keep checking, looking for the crossover to find where the internal rate of return is. So if we enter 21, 22, 23, 24, what do we get in our calculator? So if I enter 21, it's still positive. If I enter 22, it's still positive. If I enter 23, if I enter 23, it's still positive, you see? And now what's going to happen when I enter 24? It's going to be negative. Now, you might not understand what I'm saying because it's late and it's Friday. Tomorrow it'll be more fresh. So I enter 24 and I ask for NPV and it went to negative. So what happened is that as I was changing the discount rate, the NPV crossed over from a positive project, from a valuable project, or so a profitable project, to not profitable project. All right. So with that, I will leave you, if you have time, with Taylor tomorrow in the morning. Look at all your questions, review the materials I've given you. I've given you some review assignments with this, but we're going to pick up here tomorrow and talk about some of the challenges using internal rate of return. Okay, so if you have any questions, let me know in the chat. Required rate of return, yeah. Okay, no questions? So we'll talk more about internal rate of return. We'll spend most of the time in the first class on finishing these notes, and then we'll solve some problems together. Okay? And I can answer questions that you have about the other material as well. Okay, so I'm going to say bonsoir to anybody who needs to get going. If you have some questions, I will stay on here. But otherwise, enjoy your work with Taylor tomorrow. We'll see you tomorrow.